I want to try to relate this as much as I can to the unit circle today. We're going to graph two periods of each equation. We've graphed sine and cosine. That's 2 of the 6. We're going to finish up 4 all in one shot here. And the reason we can do that is because if you know sine and cosine, I think you're going to be okay with these graphs here. Let's talk a little bit about cosecant as we go around the unit circle. So here we have 1, 0, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosecant is the reciprocal of sine, so we're going to kind of look at what sine is as we go around the circle. Sine is 0. Reciprocal of that is undefined. This will be 1. Here we have undefined again, and then we have negative 1, and then back to undefined. Now, what does undefined mean as far as the graph is concerned? Well, remember, cosecant is 1 over the sine of, in this case, x. Well, if sine is 0, then you have 0 in the denominator. And if you go back to our rational functions, where we had 2x minus 1 divided by 3x plus 3, we had horizontal asymptotes, we had vertical asymptotes, we had x-intercepts, y-intercepts, all this kind of stuff. And vertical asymptotes happened where the denominator was 0. Well, that doesn't change just because it's sine. So with cosecant, we're going to start this out by graphing sine so we can locate our vertical asymptotes. 1, 2, 3, 4. 1, 2, 3, 4. So negative 2 pi, 2 pi. And then sine goes up to 1 and down to negative 1. And we're just going to graph sine. 0, 1, 0, negative 1, 0. Now I'll dot this because it's really not part of the graph. I won't make it solid. But it's definitely going to guide how I'm going to graph this thing. Now, anywhere sine hits 0, or let me say this, anywhere where sine hits the midline, we want vertical asymptotes. Because if you bump that midline up, that doesn't change where the vertical asymptotes are. And you're going to say, hey, you said where it's 0. Okay, I'm saying 0, and I'm saying where it hits the midline. Now, if that's the same thing like here, great. If the midline gets bumped up, you mark it where the midline is. All right, anyway. Vertical asymptotes here. There's another place at 0, 0, 0, and one more. So this curve is going to follow those asymptotes just like any other curve does. And now the reciprocal of 1 is 1, so they share that point in common. Matter of fact, they share all the 1s and all the negative 1s are on both graphs. And now we just make the curve follow those asymptotes. And we can't cross the x-axis because that would suggest some x-intercepts, and we don't have that. So what you end up doing is just turn the graph upside down. That's it. There's cosecant. So if you can graph sine and turn it upside down, you're good to go. So the trick really is still being able to graph sine. Can you do that? Can you do what we've been doing the past few days? All right, what if it's a little bit more complicated, or a lot more complicated? What if we have that one? Secant is the reciprocal of cosine. So really, we're going to graph this. Y equals 2 cosine x minus pi over 4 plus 1. And then turn it upside down. That's it. That's the name of the game. Well, if the amplitude is 2 and we're moving up 1, I'll have to go up to 3 for sure and maybe leave a little bit more room than that. 1, 2, 3, 4. It's nice if you plan a little bit ahead. That's probably a decent graph right there, or set it up anyway. The period does not change. The coefficient of x is 1. So the fourth mark, 1, 2, 3, 4, is still 2 pi and negative 2 pi. Over pi over 4. Well, this is pi. This is pi over 2. So over pi over 4 means we're going to move it over 1 mark, right? Mm-hmm. Absolutely. Thanks for playing along. That was funny. She must have heard about your hand. She wants to see it, I guess. Just kidding. All right, so half a mark. We got to move it. Half a mark to the right. Everybody up 1. So now we have a new midline. Now, it's not so much where this graph is 0 anymore, but where it hits the midline. That's where we have those vertical asymptotes. All right, so we moved everybody up. I got to make an amplitude of 2 and bump everybody to the right. And this is cosine. So cosine starts up here at 3, and I've bumped it over a half a unit to the right. Then it goes to 0, and then down to its lowest value, back to 0, and then up to its highest value. There we go. And then midline, lowest, midline, and then up here at the highest, which is up there. There we go. So there's the W we're kind of getting used to seeing possibly. And then now anywhere this graph hits the midline, we're going to have a vertical asymptote right there. There. And these should be cutting right through the middle of my markings, but there's going to be a little bit of error there. That's pretty decent, right down the middle. And then, just turn everything upside down. So turn that upside down, turn those upside down, and the rest of them. There we go. So the solid lines is the actual graph. Now, if you're going to try to, check your answers, use your calculator to check your answers. To do cosecant, you'd have to do 1 over sine. You don't have a cosecant button. So 1 over sine, and here's how I recommend you set up your window. You go negative 2 pi to 2 pi, and it changes everything to decimals. And then normally you see a 1 there. Well, don't go by ones. 1 radian, we don't mark stuff off in ones usually. So I would just go maybe pi divided by 4. And then with your y-axis, you can do pretty much anything you want with that. But when you graph this one, then every one of those marks represents pi over 4. So that's how I'd set up the graphs if you're going to use your calculator to check your answers. All right, how about tangent? We're going to do tangent and then a cotangent. We'll talk about the differences. Let's look at the values as we go around the unit circle. One 0, 0, 1, negative 1, 0, 0, negative 1. With tangent and cotangent, we really like to graph between the vertical asymptotes. So look right here. You have sine over cosine. That's tangent. Sine over cosine. So the denominator is 0. So we're going to have a vertical asymptote there. Then, if we do sine over cosine here, you get 0. You get a value of 0. And then up here at pi over 2, you get undefined again, or another vertical asymptote. But look, there's some really nice values along the way. We go from undefined to negative pi over 4 is negative 1. It's square root of 2 over 2, negative square root of 2 over 2 divided by square root of 2 over 2. That's negative 1. So it goes asymptote, negative 1, 0, and then pi over 4 is a value of 1. That's really nice. That's not some ugly decimal or some ugly radical. So undefined, negative 1, 0, 1, undefined. And then when you get to the other half of the circle, all the values repeat. So what does that mean? What kind of information would that give you? Scott, what do you think? No, it's the same thing, as a matter of fact. So what does that tell us about tangent? It repeats, right? Okay, what does that mean? Same thing. What are we talking about here? What's that? The period is pi. So the period for sine and cosine, 2 pi. Once you get to 2 pi, it all repeats all over again. My turn. Pi repeats itself every pi. Period. Pi. That's a big deal. That's a big deal. So you don't have to go to 2 pi for tangent to repeat. It'll repeat in half that time. All right, great. Here we go. So here's negative 2 pi, and here's 2 pi. And we just found out we don't need to go that wide to get one period of tangent. Matter of fact, there's going to be a whole bunch of them now. Tangent is sine of x over cosine of x. And the name of the game today is to find the vertical asymptotes. So that means in order to graph tangent, we're going to graph cosine and then find out where that's 0 or where that's hitting the midline. Same thing. So cosine starts at 1, if that's 1 right there, and then 0, negative 1, 0, 1. No, I missed, didn't I? I messed that up. 0, negative 1, 0, 1. There we go. And I'll dot that because it's not really part of the graph. It's going to help me. It's going to guide me in graphing it, but it's not part of it. And then now, here's where all your vertical asymptotes are. But look where they are. Here's negative pi over 2 right there, right where we said it would be, right at negative pi over 2. And here's another one at pi over 2. But there's another one if I'm going from negative 2 pi to 2 pi. There's a whole bunch of them. All right, so we got those. Now what are we going to do? We're going to look at the very middle, right? Split over the y-axis. If we go from negative pi over 2 to pi over 2, from here to here, these are the principal quadrants, by the way, undefined, negative 1, 0, 1. Negative 1, 0, 1, that's the order. So as we go from negative pi over 2 to pi over 2, it goes negative 1 at negative pi over 4, 0 at 0, and 1 at pi over 4. And then tangent just follows these asymptotes. Like that. Now that, if I said graph one period of tangent, that's the one you would do, right down the middle of the y-axis. But there's more of them. So it goes negative 1, 0, 1 again. That would happen. And then it'd go negative 1, 0, and we're at 2 pi. So we got to stop eventually. Then we have negative 1, 0, and 1. So here's a whole bunch of periods of tangent. And then 0, 1. How come she gets applause? I never get applause. Thanks a lot. Any questions on that? All right, here we go. Secant, cosecant, tangent, cotangent. They don't have amplitude. That's just sine and cosine. They don't have a top value and a bottom value. They're shooting off to infinities and negative infinities. So this 2 right here is not really amplitude. It just stretches the graph vertically by a factor of 2. It's one of your transformations. But it's not amplitude on cotangent. All right, so this is equal to cotangent is cosine over sine. We want to graph y equals 2 sine of x plus pi over 6. And then we'll talk a little bit about cotangent. The sine is going to give us the 0 values, or that's where we want to see where the graph hits the midline or zeros. So 1, 2, 3, 4. There's no coefficient of x, or it's 1, I should say. So the period doesn't change, at least for sine. I'll go up to 2 and down to negative 2, and everybody gets pushed over pi over 6. And when I was looking at the homework, there was a couple of them where you had to push it over pi over 6. Just kind of a pain, but we'll kind of estimate it as close as we can. If you look at the unit circle, if this right here is pi over 2, pi over 6 is about right there. So it's not quite halfway. So not quite halfway, I got to push it to the left. Everything gets pushed to the left. So how about right there? Not quite halfway. We'll call that pi over 6. Push to the left. And I'm graphing sine, so I'm at 0. Here's 1, here's 2. Negative 1, negative 2. And then up to 2, back to 0, down to negative 2, back to 0. Here, right there, 0, 2, 0. All right. We got it. Well, now, where are the vertical asymptote? There's one, I haven't done them yet. So we're hitting the zeros, or where the graph hits the midline. That will make the denominator of cosine over sine 0. That's where your vertical asymptotes are. Now remember, this got pushed left by pi over 6, but if it hadn't, we would have undefined at 0 because that's 1, 0. There's cosine over sine, right? Cosine over sine. So there's undefined. Well, look how cotangent goes. It goes 0, 1, 0. Excuse me. Undefined, 1, 0, negative 1, undefined. We like those pi over 4s because it's just 1s or negative 1s. So look, if you go from this vertical asymptote to the other one as you work your way across, you're working your way across this way on the unit circle. So asymptote, 1, 0, negative 1, asymptote. So that does this. Right here down the middle, all right, that's right down the middle of those asymptotes, it's going to be 0. And we multiplied everything by 2. So right down the middle there is 2. Right down the middle right here is negative 2. And it does that. Aha! So by following the zeros, the 1s, and the negative 1s, this is what tangent does right here. When I think about graphing tangent, I think about x to the third. This is what x to the third kind of looks like. Cotangent, we're going down as we go left to right. So tangent goes up as we go left to right. Cotangent down as we go left to right. That's why this one's going down now instead of going up like tangent did. And then now we have a 0 right here. 2, negative 2, cotangent. Right down the middle, right here, 0, 2, negative 2. Here's another one, and we got one more. 0, 2 right here, negative 2 right there. So this has been stretched vertically and moved left. Any questions? If I ask you to graph one period of cotangent, it's from 0 to pi. That's the one we look at right there. That's the one that you would graph. You wouldn't go 5 periods to the left and give me that one. You'd go from 0 to pi. That's the one you'd show me. Last one. I know I'm talking a lot today compared to most days. But I had a lot to say today. I want to talk about this one real quick, and then I'll be done. I'll give you whatever's left to work on homework. Graph the function y equals 3 sine. And the reason I'm talking about this one is because if you see this instructions right there, those right there, good grammar, huh? Negative 3 pi over 2 to pi over 2. We got to go up to 3, 1, 2, 3, down to negative 3, and we're graphing sine. 1, 2, 3, 4. 2 pi, 1, 2, 3, 4. Negative 2 pi. The reason I'm showing you this today is if you graph it farther than what you are told to, I will take points off. I just want you to know how I'm going to grade it. So don't go farther than what you've been told to do. So this is negative 3 pi over 2 right there, and this mark right here is pi over 2. But otherwise, you graph it the exact same way. Sine starts at 0, goes up to 3, but then stop. You've made it. So down to negative 3, back to 0, up to 3. So I'm only going to graph it that much right there. Don't go beyond that, or I'm going to count it wrong because it specifically said what to graph it to. And I don't want you to get any points off your tests or quizzes because you just didn't understand the instructions. So that's why I showed you this last one. Any questions? Awesome.